Welcome to this deep dive. We're tackling a really core concept today, especially if you're prepping for those senior-level IT specialist interviews.
That's right. Java inheritance.
Exactly.
Yeah.
It's fundamental for showing you truly grasp object-oriented programming. We're going to unpack it all.
Everything from extends, super and subclasses, method inheritance, overriding.
Subclass construction, superclass assignments, casting, even those slightly tricky anonymous subclasses and method expressions with super.
Our aim is really to give you those aha moments.
Oh.
Understanding how inheritance helps with code reuse and polymorphism is key.
Vital for system design and definitely vital for nailing those interviews. So let's jump right in. Where do we start?
Let's lay the foundation first. Extending classes, that whole superclass and subclass relationship.
Right, the extends keyword.
Precisely. That's how you create a new class, the subclass, which gets things from an existing class, the superclass. Think employee and manager.
Okay, so employee is the existing one, the superclass.
And then manager is the new one, the subclass, that extends employee.
Got it. Employee is the superclass, manager is the subclass. But it always feels a bit funny, doesn't it? The names super and sub, because the subclass actually has more features.
That's a really important point to grasp. A manager does more, or can do more, than a general employee. It's not superior in capability.
So why the names?
Think set theory. The set of all managers is a subset of all employees. Every manager is an employee.
Okay. But not every employee is a manager. That makes sense. So the subclass inherits everything and then adds its own specific stuff.
Exactly. Which leads us nicely into defining methods in the subclass.
Like our manager. Managers often get bonuses, something regular employees might not have.
Right. So the manager class would need its own specific method, maybe set bonus.
How would that work?
Well, you'd likely have a private instance variable, say private double bonus, and then a method like public void set bonus, double bonus.
Okay, take spell.
And it would probably just do this dot bonus equals bonus. Simple assignment.
And a manager object can just call that directly.
Yes, because it's defined right there in the manager class. But here's the inheritance magic. The manager can also use methods from the employee class.
As long as they're not private.
Correct. Non-private methods are automatically inherited. Huge for code reuse.
So if employee had, say, a raise salary method,
Public void raise salary, double percentage perhaps?
then a manager object could just call raise salary directly, even though the code isn't physically typed into the manager.java file.
Absolutely. That's inheritance in action. You could conceptually have code like this.
Okay.
Manager space boss equals new space manager, open parenthesis, some arguments, close parenthesis, semicolon.
Creates the manager object.
Then you call the manager specific method, boss.set bonus, open parenthesis, 10,000 close parenthesis, semicolon.
That's the bonus.
And then call the inherited method, boss.raise salary, open parenthesis, 5, close parenthesis, semicolon.
Raises salary by 5% using the employee class's logic. Very clear.
It shows both types of method access perfectly.
Now, what if the inherited method isn't quite right for the subclass? Like getting the salary. A manager's salary should probably include their bonus.
Exactly. That's a classic scenario. And it brings us to method overriding. The employee's get salary might just return the base salary.
But the manager needs to return base salary plus the bonus.
So the manager class overrides the get salary method it inherited from employee. It provides its own specialized version.
And the key thing when overriding is the signature has to match exactly. Name and parameter types.
Paramount. Absolutely critical. Same name, same parameter types in the same order. If you change anything in the parameters, you're not overriding anything.
You're overloading, creating a new method.
Right. Which can cause really subtle bugs because you think you're overriding, but you're not.
So how do we make sure we're overriding correctly? There's that annotation.
Yes. The override annotation, spelled A-DT override.
Yeah.
You put it right above the method declaration in the subclass.
At override. What does it actually do?
It's a signal to the compiler and to other developers reading the code. It says, my intention here is to override a method from the superclass.
And the benefit.
The compiler checks for you. If you misspell the method name, or if the parameters don't match any method in the superclass or its ancestors, the compiler gives you an error right away.
Prevents runtime surprises.
Definitely. It catches those mistakes early. Always use @override when you intend to override. It's just good practice.
Okay, so inside the manager's overridden get salary, how do we get the original employee salary before adding the bonus? You mentioned super.
Right. Inside the overriding method, you can use super.method name. So in manager's get salary, you'd probably write something like return super.getSalary plus bonus semicolon.
So super.getSalary calls the employee version.
Exactly. It explicitly tells the JVM, go find the implementation of getSalary in my immediate superclass employee and run that. Then you take the result and add the bonus.
It's not like super is a whole separate object then.
No, that's a common misconception. It's more like a directive to start the method lookup in the superclass for this specific method call on the current object.
Got it. Now, you also touched on something called covariant return types. Sounds a bit fancy.
It does sound a bit academic, but the idea is pretty useful. When you override a method, Java lets you change the return type.
Oh, I thought it had to match.
The parameters must match exactly, but the return type can be changed to a subtype of the original return type.
Okay, bad example.
Let's say employee has public employee get supervisor. The manager class could override this and declare it as public manager get supervisor.
Because manager is a subtype of employee.
Precisely. It lets the overriding method provide a more specific type back to the caller, which can sometimes avoid the need for casting later on.
Makes sense. Are there rules about accessibility, like public, private, protected?
Yes, absolutely. A very important rule. The overriding method in the subclass cannot be less accessible than the method it overrides in the superclass.
So if the employee method is public,
the manager's overriding method must also be public. You can't make it protected or private.
what happens if you try?
Yeah.
Or just forget the public keyword?
The compiler will complain. It'll give you an error about attempting to assign weaker access privileges. It's a common mistake, actually, forgetting the public on the override.
Good to know the compiler catches that.
Yeah.
Okay, let's talk construction. Building a subclass object, it's not just calling the subclass constructor, right?
No, because the subclass object also has all the instance variables from the superclass, and those need to be initialized.
But the subclass constructor can't directly touch the superclass's private variables.
Correct. So the subclass constructor must call a superclass constructor to handle the initialization of those inherited parts.
And that's done using super.
Yes. You use the super keyword, but this time like a method call with parentheses, super. You typically pass arguments to it to match a specific constructor in the superclass.
So in our manager constructor, we'd probably call super with the name and salary?
Exactly. If employee has a constructor like employee, string name, double salary, the manager constructor might look like public manager, string name, double salary, open curly brace, super open parenthesis name, salary close parenthesis semicolon bonus equals 0 semicolon close curly brace.
And that super name salary call. Does it matter where it goes in the constructor?
Yes. It must be the very first statement in the subclass constructor, no code before it.
The absolute first thing. Why?
Because the superclass part of the object has to be fully initialized before the subclass starts doing its own initialization, like setting the bonus to 0 in our example.
Okay, makes logical sense. What if you just forget to put a super call in?
If you don't explicitly call super with arguments, the compiler automatically inserts a call to super with no arguments.
It calls the default no argument constructor of the superclass.
Yes. But here's the catch. If the superclass doesn't have a no argument constructor, maybe you only defined constructors that take arguments, then you'll get a compile time error. The compiler can't find a suitable superclass constructor to call implicitly.
Right, so you either need to ensure the superclass has a no-arg constructor, or you must explicitly call an existing superclass constructor using super with the correct arguments.
Exactly. You have to make sure that superclass initialization path is covered.
Okay, let's shift to superclass assignments. This sounds powerful.
It is. It's a cornerstone of polymorphism in Java. You can take an object of a subclass, like our manager,
Manager, boss, new manager.
and assign it to a variable declared as the superclass type.
Employee, empl is boss. That's allowed.
Perfectly legal, because remember, a manager is an employee. It fits the type.
Okay, so employee is type employee, but it's actually pointing to a manager object. What happens when you call a method on empl, like empl and get salary?
Ah, this is where a dynamic method lookup comes in, or virtual method invocation, you'll hear it called.
Dynamic lookup.
Even though the variable empl is declared as employee, the Java virtual machine looks at the actual object it's referencing at runtime.
Which is a manager.
Right. So when you call empl.getSalary, the JVM executes the getSalary method that's defined in the manager class, the overridden version that includes the bonus.
Wow. So the actual method that runs depends on the object's true type at runtime, not the variable's declared type.
Precisely. That's what makes inheritance so flexible. You can write code that works with employee references.
Like looping through an array of employees.
Exactly. And you don't need to know if each specific element is just an employee or a manager or some other future subclass. When you call getSalary on each one, the correct version for that object's actual class gets executed automatically.
That's incredibly useful for building systems that can be extended later without rewriting the core logic.
Absolutely. Think about processing different kinds of documents or handling different shapes in a drawing program. You work with the general type, and polymorphism handles the specifics.
Now, you mentioned arrays. There's something about arrays and this superclass, subclass relationship.
Yeah.
Array covariance.
Yes, this is a bit of a quirk in Java's type system, specifically with arrays. Java arrays are covariant.
Meaning?
Meaning you can assign an array of a subclass type to a variable declared as an array of the superclass type.
So, like, manager array bosses equals new space manager array, open bracket 10, close bracket semicolon.
Okay, you have an array that can hold 10 managers.
Employee array empls equals bosses semicolon. That's allowed.
Yes, that compiles fine. Because manager is a subtype of employee, Java allows manager to be treated as a subtype of employee.
Okay, but what's the danger? It seems convenient.
The danger comes when you try to write to that array through the superclass reference. The compiler sees empls as an employee array.
So it thinks putting a regular employee in is fine. Empls open bracket 0 close bracket equals new employees, 30,000 semicolon.
The compiler allows that line. But at runtime, remember, empls is actually pointing to the original array, which was created as new manager 10.
And you can't store a plain employee in a manager array.
Exactly. So at runtime, that line will throw an array store exception. Bang.
Ouch. So array covariance is legal at compile time, but can blow up at runtime if you're not careful.
Right. It breaks type safety at runtime. This is actually one reason why using generic collections like ArrayList employee is generally preferred over raw arrays these days. Generics handle these type issues much more safely at compile time.
Good point. Okay, so we have this employee variable empl holding a manager object. We know empl.getSalary calls the manager's version, but what if we want to call setBonus, which only exists in manager?
Right. If you try empl.setBonus $1,000, the compiler will stop you.
Why?
Because the compiler only looks at the declared type of empl, which is employee. And the employee class doesn't have a setBonus method. The compiler doesn't know, or doesn't assume, that empl might be holding a manager at runtime.
So even if we, the programmer, know it's a manager, the compiler won't let us call setBonus through the employee reference. How do we get around that?
We need to tell the compiler, trust me, this employee reference is actually holding a manager, so treat it like one. We do that with a cast.
Ah, casting. Like with numbers.
Similar idea, but before you cast, it's really good practice to check if the object is actually the type you expect.
How do you check?
Using the instance of operator, you'd write, if open parenthesis, empl instance of manager close parenthesis.
Checks if the object empl points to is, in fact, a manager or a subclass of manager.
Exactly. If that check passes, then it's safe to cast.
And the cast itself looks like?
You put the target type in parentheses before the variable. So inside the if block, manager space mbr equals open parenthesis manager close parenthesis empl semicolon.
Okay, manager empl, that tells the compiler to treat empl as a manager for this assignment.
Right. Now, mbr is a variable of type manager, and the compiler knows it. So now you can safely call the manager-specific method, mbr.setBonus, open parenthesis, 10,000, close parenthesis, semicolon.
And because we did the instance of check first, we avoid a potential class cast exception at runtime if empl wasn't actually holding a manager.
Precisely. The instance of check followed by the cast is the standard safe way to access subclass-specific members when you only have a superclass reference.
Okay, that makes sense. Now for something maybe a bit less common, anonymous subclasses.
Right, anonymous inner classes. You can create them to implement interfaces, but you can also create them to extend a superclass directly.
Without giving the new subclass a name.
Exactly. It's useful for small, one-off customizations of a class, often right at the point where you need the instance. The source mentioned a debugging use case, which is interesting.
Like overriding a method just to add some logging or something.
Yeah, exactly. The example given was overriding the add method of ArrayList just to print a message whenever an element is added.
How does the syntax for that look? It sounds complex.
It's a bit dense, but logical once you see it. You'd write something like, var space names equals new space array list of less than string greater than open parenthesis 100 close parenthesis open curly brace.
Okay, starting like a normal array list, but with an open curly brace at the end.
Yes, that open curly brace signals you're defining an anonymous subclass right here. Inside the braces, you define the members you want to add or override.
So for the example,
And to put A, override public void add, open parenthesis in index, string element close parenthesis, open curly brace super dot add, open parenthesis index, element close parenthesis semicolon system dot out dot print open parenthesis double quote, adding space % space at space % d backslash n double quote comma element comma index close parenthesis semicolon close curly brace semicolon.
wow, okay. So the add override is there, the call to super.add to get the original behavior, and then the print. And the whole thing ends with a closing curly brace and a semicolon.
Right. You're defining the class and creating an instance of it all in one go. The open parenthesis 100 close parenthesis part is still calling the desired array list superclass constructor.
It's compact, but maybe a little hard to read if overused.
It can be, yes. And there was that other related pattern mentioned, double brace initialization.
Yeah, that sounded weird. For
Yeah.
initializing an array list.
It's a sort of trick. You combine the anonymous subclass syntax with an instance initializer block. Looks like this. Invite open parenthesis, new space array list of less than string greater than open parenthesis, open curly brace, open curly brace.
Two open curly braces.
Yes. The outer one starts the anonymous subclass of array list. The inner one starts an instance initializer block within that anonymous subclass.
And inside that inner block.
You just make calls to instance methods like add. So add open parenthesis, double quote close parenthesis semicolon, add open parenthesis, double quote Sally, double quote close parenthesis semicolon, close curly brace, close parenthesis semicolon.
So outer braces define the anonymous subclass. Inner braces are the initializer block where you call add multiple times.
Technically, yes. It looks like a shortcut for creating and populating a list inline.
But is it a good idea?
Generally, no. Not for production code. It seems clever, but it creates an unnecessary anonymous subclass instance every time. This can have weird side effects, especially with equality checks, equals method, and can be less efficient.
So better alternatives exist.
Definitely. For creating simple, immutable lists, list jot of open parenthesis, close parenthesis is much clearer, safer, and generally the way to go in modern Java. Avoid double brace initialization.
Good advice. Okay, last major topic, method expressions using super.
Right. We know method expressions like object.instance method. You can also use super where you'd normally put the object reference.
Super.instance method.
Yes, super double colon instance method name. It creates a reference to the superclass's version of that instance method, bound to the current object.
Okay, why would you do that? The current worker example might help.
Let's walk through it. Imagine a simple worker class. Public class worker, open curly brace, public void work, open curly brace loop printing, working, close curly brace, close curly brace.
Okay, a basic work method.
Now a subclass. Public class concurrent worker extends worker open curly brace. And we override work, public void work, open curly brace.
What does the concurrent version do?
It wants to run the original worker's work method, but in a separate thread. So inside concurrent worker's work method, var space equals new space. Thread open parenthesis, super double colon work, close parenthesis, semicolon, t dot, start open parenthesis, close parenthesis, semicolon, close curly brace.
Ah, so super.work. That's super double colon work. What does that create?
It creates an instance of a functional interface, specifically a runnable in this case, because that's what the thread constructor expects.
And when that runnables run method is called by the new thread,
it executes the work method from the worker superclass using the current concurrent worker object as the instance. So it effectively runs the superclass's work logic in a background thread.
That's neat. A concise way to pass the superclass implementation as behavior.
Exactly. Very useful in functional programming contexts or when dealing with APIs that expect functional interfaces like runnable or callable.
This has been incredibly thorough. Thinking about senior interviews, mastering these details really seems non-negotiable.
Absolutely. Interviewers will probe your understanding of these concepts deeply. Shall we run through some typical questions you might encounter?
Yes, let's. What kind of things should our listeners be ready for?
Okay. Expect questions like, explain the fundamental principles of inheritance in Java. How does it contribute to code reuse and maintainability in software development?
Classic opener. Tests the core understanding.
Right. Then maybe. What are the key differences between method overriding and method overloading in Java? Provide clear examples to illustrate each concept.
Distinguishing those two is crucial.
When and why would you choose to use the add override annotation, that's attack Qt override annotation in your Java code? What are the potential consequences of using it incorrectly or omitting it when overriding?
Testing best practices and error prevention. Good one.
Also, describe the purpose and functionality of the super keyword in Java. Explain how it is used within subclass constructors and when overriding methods.
Two distinct uses of super. Important.
Explain the concept of dynamic method lookup, sometimes referred to as virtual method invocation, in the context of Java inheritance. Why is this a significant aspect of polymorphism?
The runtime magic. Definitely a senior level topic.
Is it permissible to assign an object of a subclass to a reference variable of its superclass type in Java? Discuss the implications and any limitations associated with doing so.
The employee in a pill in place of boss scenario.
What is array covariance in Java? Describe a scenario where it might seem convenient but could potentially lead to runtime errors. How do generics address this issue with collections?
That array store exception pitfall.
When you have a superclass reference that is actually pointing to a subclass object, how can you access methods that are specific to the subclass? Explain the role of casting and the instance of operator in this process.
Getting back to those subclass methods safely.
Describe a practical use case for anonymous inner classes that extend a superclass in Java. Can you provide a code example illustrating such a scenario? What are some trade-offs to consider when using anonymous inner classes?
Testing knowledge of less common but still relevant features.
Explain how method expressions can be used in conjunction with the super keyword in Java. Provide a concrete example to demonstrate its usage and the benefits it offers, particularly in functional programming contexts, like our concurrent worker.
Right, super double colon method name.
In the context of inheritance, what are the rules governing the accessibility of methods that are overridden in a subclass? Why are these rules important for maintaining the principles of object-oriented design?
Can't weaken access.
And finally, what is a covariant return type in Java? Can you provide an example of a scenario where using a covariant return type would be beneficial and why?
Making sure the more subtle points are covered too. Those are great examples.
Being able to discuss these confidently shows a real depth of understanding.
Absolutely. So to quickly recap our deep dive today, we covered extending classes with extends, the whole superclass subclass dynamic, how methods are inherited and defined, the critical concept of method overriding, including the at override annotation.
Subclass construction, using super, assigning subclass objects to superclass variables, enabling dynamic method lookup, the need for casting with instance of.
Those anonymous subclasses, even the double brace caution, and finishing with super in method expressions like super double colon method name.
It's a lot, but it all ties together. And understanding it isn't just for interviews, it's fundamental for writing good, object-oriented Java code.
Couldn't agree more. It impacts how you design and structure complex applications every day.
Knowing when to use inheritance, and maybe sometimes when not to favor composition instead, is key for senior developers.
Exactly. Which brings us to a final thought for you, our listeners, to think about after this. Consider this. Inheritance is undeniably powerful for code reuse and organization. But it can also create tight coupling and make systems harder to change if overused or misused.
It's a double-edged sword sometimes.
So the question to ponder is, what strategies can you employ in your own designs to harness the power of inheritance while actively mitigating the potential complexities it might introduce, especially in large, evolving systems? How do you balance inheritance against other design principles to keep your software flexible and maintainable?
Some real-world trade-offs to consider there.
Definitely. Food for thought. Thank you for joining us on this deep dive into Java inheritance.